Hi, I'm Steve and welcome back to my channel. In this video I'm going to be explaining how the ignition system works, and this video will apply to all cars that have a mechanical distributor with mechanical contact breakers, so it applies to everyone. So the first thing in the ignition circuit is the coil, and this is what creates the high voltage to create a spark at the spark plug. Now this is the negative side on these cars because it's a positive earth. So this side is energized when you turn your ignition on, and this side is connected to the points, and the other side of the points are connected to earth. Now what happens is you've got a primary winding that is a few hundred turns of coarse wire connected to these two, and inside that primary winding there's a secondary winding that is a much finer wire, and it has thousands of turns in there. So what happens is the coil is energized when the points are closed, and then as the points open, the magnetic field that is created collapses, and as the magnetic field collapses, that induces a high voltage in the secondary winding, which goes up to your distributor, and then it's distributed to the 4 plugs in turn. But I've just got one here, so what I'm going to do is use this battery. So that's connected to the negative side of the battery there, so that's like your ignition is on. And when I connect this side, it's like the points are closed, and as the points open it sparks. So the points are closed, it energizes, and then as it opens it sparks. What I'm going to do now is I'll zoom in on here. Don't know if we can get this very good. It's on and off. So the points are closed and open, and then when it opens it sparks. So that's how the spark is created. When you time an engine, it's all about getting the correct ignition advance. So that means that it sparks before this gets to the top. So I've got this on the compression stroke. Both the cam followers are down, so I know it's on the compression stroke. I've set this clock so it's on 0 when the piston is right at top dead center. So as you can see, when it comes to this timing mark here, it's about near enough 25 thou. So from there to 0 is 25 thou. So then this is the point at which it sparks. So then it has to go a bit more up a bit more until it's at the top. So that is the ignition advance, and I've written on here 11 degrees because that's what they say it is in the book. So that is 11 degrees. Now the reason for this is, I think they discovered this about 100 years ago, that because this is going up and down so fast, it will take a split second for the gases to start expanding and pushing the piston down again. So they don't want the gases to be expanding when it's like down there, because you've missed this part of the stroke, power stroke. So they ignite it before it gets to the top, so that by the time the piston is on its way down again, the gases are just starting to expand and you get full power right from the very top. Now as the engine speeds up, you need to have it a bit more advanced, because it's going quicker, but the gases still take the same amount of time to expand. So you need to ignite it a little bit even more before it gets to the top as the speed goes up. And that's what the advance is, and that's what the distributor does with the mechanical advance and the vacuum advance. So now I'm going to go into that. Right, I've stripped this distributor down just to demonstrate the mechanical advance. So as you can see from the rotor, it goes in an anti-clockwise direction. Now when it's running, these weights come out as the engine speeds up. So if you look at this part of the cam, you can see that's going in, also going in an anti-clockwise direction, which has the effect of advancing the ignition, because the points are not moving, the points are staying still, but the cam is being advanced. That last clip was over a week ago, because when I tested the vacuum advance, I realised the original one was leaking, because in here there's a rubber diaphragm, and one side of it is connected to this lever here, and the other side is connected to the carburetor that creates the vacuum. Now the way to test these is simple. You just get a bit of pipe on the end, or you can use the original metal pipe. And what you do is you put this in your mouth and you suck. So what I'm going to do, I'm going to suck it, and then this is going to move. Then I'm going to put my tongue on the end of the pipe, and it should stay where it is. If it doesn't stay where it is, that means you've got a leak. So I'm going to do it now. So as you can see, as I took my tongue off the pipe, it went back. When I was looking around on the internet, I discovered something that I didn't know, that these vacuum units are all different ratings. There's lots of different types. Now these numbers on here, they are rated in inches of mercury, and that's a way of measuring how much vacuum you have. So what these numbers mean is, the 3 means that it should start advancing at 3 inches of mercury, and it should stop advancing at 15 inches of mercury. Now the 9 is not a vacuum number. The 9 is the degrees of advance that you should get when you get to 15. So that means it's degrees of the points, not of the crankshaft. So actually that 9 means that it's advancing the engine at the crankshaft by 18 degrees. So that means that when you've got your foot right down going up a hill or something, that's going to be the maximum advance that you're going to get. I've got a way of checking this, because this unit here is a vacuum generator, and it works by passing compressed air through there and coming out of here, and there's a Venturi effect, and it creates a vacuum in this port here. So I've got this T-piece, and I bought this gauge. Now this gauge is in inches of mercury here. So this is the 3 and this is the 15. So as I open this valve, it should start moving when it gets to there, and it should stop moving when it gets to there. Now I wanted a way of checking how much advance it's doing. So what I've done is, this is the calculation. I've measured the inside diameter of this distributor, and it turns out it's 2.66. So the circumference turns out to be 8.356. So I divided by 360 to give 1 degrees, and then I multiplied that by 9 to give 9 degrees. And so the distance between these two marks here is 0.208. So that is 9 degrees of advance. So now I'm going to slowly turn this on, and you should be able to see it moving. So as you can see, it's just started to move there, about 3 degrees, so that's correct. So then I wind it up to 15, and so those two lines now are in line. It's a little bit short. It was very difficult to film this with this and the gauge in view, but you're looking at this at an angle. Now that line does line up with that, even though it looked as though it didn't. But it does take a little bit more than 15. But you know, I think that's fine. I'm not worried about a few divisions on the scale. It is actually advancing exactly 9 degrees, so that is good. Now this came from a company called Distributor Doctor. It's one guy who does it, I think, and he has these. This was in stock, so he cuts the original one off, and then he puts this band round there and puts a new end on it with a new diaphragm in there. I don't know if this is the original end that he took off of mine, but it's got the same figures on it, and as you just seen, it's working fine, and it is actually advancing what it should do. So that's a success for me, I think. I will be putting a link in the description to the Distributor Doctor. He did a very fast turnaround. He did it within a couple of days. I sent it on the Friday and I had it midweek. So yeah, very pleased with that.